Myself, Chennamma Galapnagar, Class BSc 6th Sem, Subject Chemistry, Combination Chemistry and Zoology. Question bank topic is Atomic Absorption Spectroscopy, Instrumentation and Application, Determination of Mg in a tap water, Comparison of AS and APS. Question bank. AS stands for Option A, Atomic Absorption Spectroscopy. Option B, Atomic Analysis System. Option C, Absorption Atomic Spectrum. Option D, none. Answer is Atomic Absorption Spectroscopy. Second, in AS, atoms absorb radiation in A, ground state. Option B, excited state. Option C, ionized state. Option D, plasma state. Answer is ground state. Third, the source used in AS: A, tungsten lamp. B, hollow cathode lamp. C, LED. D, mercury. Example is Answer is hollow cathode lamp. Fourth, the flame used in AS is usually A, air acetylene flame. B, hydrogen flame. C, nitrogen flame. D, oxygen flame. Answer is air acetylene flame. Fifth, the purpose of the monochromator in AS: A, increase temperature. B, select specific wavelength. C, detect a signal. D, atomize sample. Answer is select specific wavelength. The detector commonly used in AS: Option A, photomultiplier tube. Option B, thermometer. Option C, voltmeter. Option D, emitter. Answer is photomultiplier tube. 7. Magnesium is determined in water using AS due to Option A, high sensitivity. B, low cost. C, color change. D, order. Answer is high sensitivity. 8th, in AS, absorbance is proportional to concentration according to Answer is Beer-Lambert's law. 9th, in flame emission spectroscopy, measurement is based on Answer is emission of light. 10th, which technique is more sensitive? Answer is AAS. 1 mark questions. What is AAS? Technique used to measure absorption of light by free atoms. Second, what is the principle of AAS? Absorption of radiation by ground state atoms. Third, which law is followed in AAS? Beer-Lambert's law is followed in AAS. Fourth, what is the radiation source in AAS? Hollow cathode lamp radiation source in AAS. Fifth, what is atomization? Conversion of sample into free atoms is called atomization. Sixth, name the flame used in AAS. Air acetylene flame used in AAS. Seventh, what is the function of monochromator? To select a specific wavelength. Eighth, which detector is used in AS? Photomultiplier tube detector is used in AS. Ninth, what is the role of flame in AS? Atomization of sample is the role of flame in AS. 10th, give one disadvantage of FES. Lower sensitivity is the disadvantage of FES. 2 mark questions. Define atomic absorption spectroscopy. AS is an analytical technique used to determine concentration by measuring absorption of light by free atoms in the gaseous state. Second, state the principle of AAS. AAS is based on the absorption of specific wavelength radiation by ground state atoms. The amount of absorption is proportional to concentration. Third, what is hollow cathode lamp? It is a radiation source in AAS that emits characteristic wavelength of a specific element used for its detection. Fourth, what is atomization in AAS? Atomization is the process of converting a liquid sample into free gaseous atoms using a flame. Fifth, write any two applications of AS: determination of matter in water, analysis of trace element in biological sample. Sixth, define flame emission spectroscopy. FES is a technique in which atoms emit light when excited in a flame, and emitted light is measured. Seventh, give two difference between AAS and FES. AAS is based on absorption, while FES is based on emission. AAS is more sensitive than FES. Eighth, how is magnesium determined in tap water using AAS? The water sample is atomized in a flame, and Mg atoms absorb radiation at a specific wavelength. The absorbance is measured to find concentration. Ninth, what is the role of monochromator in AS? It isolates a specific wavelength of light for accurate measurement. 10th, what is the function of detector in AS? The detector measures the intensity of absorbed light and converts it into an electric signal. 5 mark questions. Explain the principle of atomic absorption spectroscopy. Atomic absorption spectroscopy is based on the principle that free atoms in the gaseous state absorb light of a specific wavelength. When a sample containing metal ion is introduced into a flame, the heat of the flame converts into free neutral atom in the ground state. These atoms can absorb radiation of a particular wavelength emitted from a hollow cathode lamp. Each element absorbed light has its own characteristic wavelength. When light passes through the flame, part of it is absorbed by the atoms and the remaining light reaches the detector. The amount of light absorbed is directly proportional to the concentration of the element present in the sample. Second, it describes the instrumentation of AS. Atomic absorption spectroscopy consists of following main parts. Light source, it emits light of a specific wavelength for an element being analyzed. Second, atomizer. The sample solution is sprayed into the flame where it converts into free atoms. Monochromator, it selects the required wavelength and removes unwanted light. Detector, it measures the intensity of light after absorption and converts it into an electrical signal. Explain the determination of magnesium in tap water using AES. The concentration of magnesium in tap water can be determined using atomic absorption spectroscopy based on absorption of light. Sample preparation. The tap water sample is filtered to remove impurities and may be diluted if necessary. Atomization. The sample is introduced into a flame where magnesium ion are converted into free Mg atoms. Next, radiation source. A hollow cathode lamp specific for a magnesium emits light of a characteristic wavelength. Absorption of light. The Mg atom in the flame absorb part of this radiation. Comparison of AES with FES. Atomic absorption spectroscopy and flame emission spectroscopy are both used for a metal analysis. Principle: AES based on absorption of light by a ground state, FES based on emission of light by excited state. Radiation source: AES used as external light source, FES no external source required, flame itself excited atom. Sensitivity: AES more sensitivity, can detect trace elements, FES less sensitivity. Accuracy: AES has a high accuracy and precision, FES has lower accuracy